Okay, good morning. Today is Monday, January 18th, and today is an E-Day. And so I'm going to give you some quick notes on just a little bit of new stuff, and then I'm going to go over a worksheet with you to review. And then your assignment for today, when you go back to our Canvas homepage and click on the load button, you will see that it is an Indicator 17 review. So it's going to be a little bit of everything that we've covered the last 2 weeks. And then tomorrow in class, we'll do a little Q&A on the review. And then we will take the quiz tomorrow in class to wrap up Indicator 17. So for today, of course, you should be in your 3-ring binder. And you need to label your notes for today, and this is Indicator 17.4, and it is Geometry, Shapes, and Figuring Area. Okay, so we are going to use what we have learned so far about multiplying monomials, and we are going to apply that to what we know about finding the area of a couple of different shapes. So the first one I want to talk about is a rectangle. Okay, a rectangle. And to find the area of a rectangle, I'm just going to use A for area. Area is length times width. Okay, length times width. So if you have a rectangle, and we have a length of 6xy squared, and we have a width of 4x squared y, okay? Now, before we jump into that, I'm going to do something very, very basic. If I had a rectangle, and I said the length was 6 and the width was 4, okay, and we know to find area, right? It's length times width, and we can also use parentheses for times. It doesn't matter. And so we would do this by simply doing 6 times 4, and 6 times 4 is 24. So if it's just numbers, I mean, it kind of just jumps out pretty easy, right? Length times width, 6 times 4, and then you get your area. Well, you do it the same way when it's a little bit longer monomial, okay? You set it up the same way. You just takes a little extra thought, but you've already done this from last week of how to multiply the variables. So let's see. Let's put our equation back up here. So whoop, not that one. Sorry about that. There we go. So we've got area equals length. Okay, and it doesn't matter which one you call length, but we're going to do 6xy squared times the width, 4x squared y. Well, now you did this last week. So to multiply monomials, remember step 1 is to start with the numbers. So 6 times 4 is just 24. And then the next step, if you look at last week's notes, was to go each variable one at a time in alphabetical order. So we're going to look at the x's first. So you've got base, so you keep your base, right? And then this exponent is really a 1. And when you're multiplying like bases, you add the exponents. So 1 plus 2 is 3. And then for your y's, you've got y, so you keep your base. And again, this is really a 1. So you've got 2 plus 1 is 3. And that's your answer. You can't reduce it anymore. You don't know what x and y are. So the area of this particular rectangle with the given information is the answer when you multiply the numbers and then each variable. So let's look at another one more quick one here. We won't do too many notes on this. So if we have a rectangle, and it can be, let me do this. If I told you that this was a square, and I give you one side length is 3a squared b to the third. And that's all I tell you. But I tell you that it's a square, okay? You know for area, you need length times width, all right? And so we only know one side length, but what do we know about a square? We know about a square is that every side is the exact same. So if I know one side, I know length, that means I also know width. So I can either write it or I can just know it, but it's 3a squared b cubed. Okay? Now you can do this one of two ways. You can do length times width, right? That's fine. 3. You can write it out twice. Okay, that works. And then 3 times 3 is 9. AA, keep your base, right? That's AAA. And you add 2 plus 2 is 4, because that's the exponent of the A here and here. So your exponent is 4. And then for B, you add B3 and B3. Or, sorry, that's 6. My bad. There we go. 3 plus 3 is 6. Okay, base, 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 add your exponents. Now, when I put the 9 there, that was just kind of me being lazy, skipping a step. Since I had like bases, right, I could do base, base, keep your base. So base, base, base is 3, so I could have kept my base of 3, and then add this exponent and this exponent. Well, 1 and 1 is 2, but 3 squared does equal 9. So I just kind of skipped that step and did it mentally. But, all right, so there is the area of the square. And the other way you could set it up, and it doesn't matter to me which way you do it, is we know that anything times itself is squared. So you could do 3a squared b cubed, and then you could square that, because squared means the same thing times itself. So this right here and this right here means the same thing. It's 3a squared b cubed, 3a squared b cubed times itself, or the squared means times itself. So if we square it, we use our power to a power rule, and that means that this 2 goes to the 3, the a, and the b. Remember, and that means that this power gets multiplied by the power of each one of these terms. And the power of 3 is 1, and so we keep all the bases, and then we take 2 times 1 is 2. We keep the base a, 2 times 2 is 4. We keep the base b, 2 times 3 is 6. And then again, we would clean that up. 3 squared is 9, a4, b6. And you can see that both times we got the exact same answer. Now, the squared thing only works when it's, or the using the power to a power and using the square idea, that only works on a perfect square. So, and any time that you are given up a square and you're only given one side length, you can set it up either one of these ways, and it both works. All right, the only other shape we're going to deal with is we're going to deal with a triangle. And so for area of a triangle, we need that formula, and that is 1/2 base times height. Okay, 1/2 base times height. So if we have a triangle, okay, and we are given that the base is 7c squared, and we are given the height, and usually that's shown by the height of the whole triangle, so it's from the center to the base, is 8c. So we need to set this up as 1/2 base times height. So area equals 1/2, and I'm going to use parentheses here just because I think it'll be a little bit easier with that half. The base, the base is 7c squared times the height, 8c. Now I'm going to ignore that 1/2 for a minute. Okay, I'm just going to drop it down and leave it alone. For right now, I'm just going to multiply the two other monomials. So ignoring that 1/2, just multiplying 7c squared times 8c. Step 1, remember, of multiplying monomials is multiply the numbers. So you've got 56, because that's 7 times 8. And then you do each variable, which here there's only one. And so it's base, base, keep your base, and then add your exponents. And we got to remember that that's a 1, so that's 3. And then the last step is to distribute that 1/2 through the monomial that's left? Well, you don't have to worry about taking 1/2 of c cubed because you don't do that. You just take 1/2 of the number. So what is 1/2 of 56? It's 28, right? 28 c cubed, and that's your answer. Okay? All right, I'm going to do one more example. And so let me scroll up here. There we go. So I'm going to draw my triangle. And I'm going to, the height of this triangle is 5 a squared b squared. And the base is 7 a squared b squared. All right, so again, we know our formula is 1/2 base times height. So like I said before, I'm going to ignore that 1/2 for right now. And I'm going to plug in my base, which is 7 a squared b squared, times my height, which is 5 a squared b squared. And again, I'm going to ignore that 1/2 for a minute, and I'm just going to multiply. 7 times 5 is 35. And then A, so keep my A. And then 2 plus 2 is 4. And then my B, 2 plus 2 is 4. And now I need to distribute that 1/2. Well, 35 is an odd number. So, and I don't want to have a decimal here. So just, if you think about, right, everything, every whole number is really over 1. This is times, right? And every whole number or monomial is really over 1. And so if you multiply a fraction times a fraction, you just multiply the top by the top. So 1 times 3a, 35, a to the 4, b to the 4 is just 35, a to the 4, b to the 4. And then you multiply across the bottom. 2 times 1 is 2. So if you have a fraction and it's an even number like we had up here, you can take 1/2 of 56 and you can get an even number. Okay, so we're going to do that and simplify it like we did up here. Down here, because 35 is not an even number, I don't want to have 17.5 up top because you don't want to do fractions and decimals all combined. So I'm just going to leave it as a fraction, and I'm going to put 35 a to the 4 b to the 4 on top, and then put the 2 on the bottom, and then that is your final answer. So when you're dealing with area of a triangle and you've got that 1/2 to deal with it at the end. And if it's an even number that's divisible by 2, reduce it. If it's not an even number divisible by 2, leave it as a fraction like we did here. Okay, so now what I want to do really quickly is I want to go out of here and I want to pull up, this would have been your homework for today. And so you don't need to do this on as a homework assignment that's going to load in Kami. I just want you to follow along, and then the only thing I want you to put in your notes here in a second, I'll tell you when we get to it. There's just a couple of these that I want you to put in your notes. So we're going to do a little bit of review, and then we're going to put just a couple more things in your notes, and then we'll be done with notes. And then your assignment for today will be to actually do the review worksheet on Kami. Okay? And then, of course, tomorrow we'll do a note check from everything from Indicator 17, which includes indicators 7.1, which was from a video last week, 7.2, 7.3, which was multiplying and dividing monomials, which we did last week, a couple Khan Academy videos from last week that you took notes on, and then the notes from this 17.4 with the shapes that you're doing today. So pretty big note check. It'll be worth more points than normal because there's more notes in there than normal, and we'll do that tomorrow while you're quizzing. All right, so just as a quick review, it says simplify, all exponents should be positive. All right, so we've got 12 to the negative 2. We have to deal with that negative by flipping the fraction over, right, because this is really 12 over 1, and so you can make it 1 over 12 squared, and then to clean it up a little bit, you could do 1 over 144, and that would be your final answer. okay? Again, you got to flip it to get rid of the negative on the exponent. Here, right, there is no negative exponent, so really just 5 cubed is 5 times 5 is 25, times 5 is 125, I believe. Okay, so that is simply dealing with exponents, and then of course if it says write your answer with no exponents, you would definitely go all the way to that end. But if it just says your all exponents should be positive, technically number 2, the exponent is already positive. So I would accept you squaring this as your answer or taking it all the way out to here if the instructions just says all exponents should be positive. If it said write your answer without exponents where possible, then you would take it all the way to here and here, okay? So if it doesn't want you to write any exponents in your answer, you definitely need to take it to what I circled in red. If it says all your exponents should be positive, technically you could stop here or you could stop here, and you would be lined up with the directions of a positive exponent, okay? All right, so now let's do this. So this was dividing monomials. Remember when I said when you're dividing monomials, give yourself a division line or a fraction line to kind of build around. And then step by step, right? Step 1, if you look at your notes from last week, was to just simplify the numbers. Well, negative 21 over 7 reduces to negative 3, or negative 3 over 1, doesn't matter to me. And then you do each individual variable on its own. Well, the easy way to do this is, there's a math way. 4 minus 5 is negative 1. Flip it to the bottom to deal with the negative. But what I would do is I look there and I've got 4 r's on top and 5 r's on bottom. I have more on bottom, so I know my r is going to end up on bottom. And don't know why that eraser was on there, but there we go. So I've got 4 r's on top, 5 r's on bottom, so I have more r's on bottom. So that means my r's are going to be on bottom, my leftovers. And I have more on bottom, and how many more do I have? I have 1 more. Why does it keep going to the eraser? Okay, my arm must be hitting something. There we go. R to the 1. And then look at your s's. Where do you have more s's? More s's on top. So I put my s on top. How many more do I have? 1. Now you can clean this up a little bit because you know in math you don't really need all those ones that are kind of silent ones. So you could clean this up a little bit and write 3s over r. Okay, that's just a nice cleaner way to write your answer. Okay, another division problem. So I'm going to give myself a fraction line. Again, 8 over 4 reduces to 2, or 2 over 1. Where do I have more y's? I have more y's on top. That means my extra y is going to be up here. And how many extras did I have? I had 1, so I'm not going to put the 1 there, but you can or not, doesn't matter. Same thing with your z's. Where do I have more? I have more on top, so that means my extras are going to go on top. How many more extras do I have? 1. Again, you can put it or not put it. Nothing goes on the bottom. Everything canceled out from the bottom, so this just is your whole answer, and you don't even really need the fraction line. All right, multiplying monomials, we know that first we multiply the number times the number, right? So 5 times 3 is 15. Then we know we multiply each base by itself, so x keeps your x. 2 plus 4 is 6. And then we also know that you do your y times your y, so you keep your y, and then 1 plus 5 is 6. And there's your final answer there, okay? And this is a power to a power, and what do we know about power to a power but that power gets multiplied by everybody else's power? Well, you have to remember that 3 does have a power to a 1, and the c has a power to a 1, and so you take the power of 3 times this 1, times this 2, times this 4, and times this 1. So it gets distributed throughout. So your bases all stay the same, right? If you start out with all these bases, 3, A, B, C, your answer should at least start forming by 3, right? Keep your base. Now, power to a power, you multiply the power of 3 times the power of 1, so that is a 3. Then go to your A. Keep your base. Power of 3 times the power of 2, that's 6. Keep your base of B. Power of 3 times 4, that's 12. And then your C, keep your base. Power of 3 times power of 1. And again, technically, since the directions said all exponents should be positive, technically you're here and you could leave it like that, or really, it's probably better, clean it up a little bit. 3 to the third power is 27, and then the rest you can't really clean up because you don't know the values, and you don't have to put that 1 there for the C. Okay? All right, again, this is back to a division problem, so I'm going to give myself a line. Now, if you're just looking at the number and you cover up all the x, y, z's, just look at your numbers. 4 over 16 reduces to 1/4. So because the 4 over 16, right, if I divide both of these by 4, I get a 1 and I get a 4. So you need to keep that 4 on the bottom, right? If you think about it in numbers, right, there's more numbers on the bottom, so your leftovers should be on the bottom. Same idea here. All right, look at your x's. I have more x's on the bottom, so that means my leftovers are going to be on the bottom. How many more do I have? 1, so I'm going to leave that a 1. My y's, I have 1 on top, and I have 3 on the bottom, so my extras are going to go on the bottom. How many more do I have? I have 2. And then my z's, I have more z's on top, so that means my extra z's are going to go on top, and that's a 1 and the 3, so I have 2 extras on top. And so there is your answer. And again, right, I'll just erase it, but you don't need that 1. I don't care if you erase it or not. You can leave it or not, but that's kind of the cleaned up version. All right, another division problem. So I'm going to give myself a division line. There's no numbers to deal with, so I can skip that step. Where do I have more m's? I have more on top. How many more do I have? Well, 5 minus 2 is 3. Where do I have more n's? Well, n3 and n3, they cancel each other out, or they're reduced to a 1. And my p, it's my only p, so it just stays my only p. And there, I don't have anything on bottom, so I can just make that my answer. On your review, I want to add something to this problem because I want to show you what you need to do here. But on your review, you're going to have something that looks like this, and you're going to have a 1/4 out to the front. Well, just like with the shapes, just ignore that 1/4 at first. Deal with it at the very, very end. So I'm just going to drop it down, and I'm going to deal with that at the very end. So ignoring that 1/4 for right now, I take 4 times 3 times 2. Well, 4 times 3 is 12, times 2 is 24, right? And then my x, y, z, so I'm going to do it in order, so I'm going to do my x's first. Well, this guy down right here doesn't have an x, so I'm going to skip it. So I have an x here and an x here, so x, keep my base. 4 plus 4 is 8. And then I go to y's, and I do have a y in every one of these. And again, I've got a y here, a y here, and a y here, and I can't forget that that's a 1. So how many y's do I have altogether? Well, I have 2, 3, 4, 5. So my new exponent here is a 5. And now that I've done kind of all of that, now I deal with that 1/4. So evenly, and again, this goes back to the does it reduce evenly or not? If I take this 1/4, right, and I take 24 over, I can stick that 4 here, right? Because 1 times 24 is 1, and 4 times 1, that would be under the 24, is a 1. So does 24 divide by 4 easily? It does. It reduces to 6. And then the rest of the stuff just stays the same. And I make this example because on your review, there's one like this where you have a couple of monomials times another monomial, and that other monomial is just a fraction. So just do the fraction last. And let me circle it in red so you can see what I'm talking about. Had this number right here not divided perfectly by 4, I would have just left this whole thing over 4. But since it did reduce perfectly, I went ahead and reduced it to a 6. Okay? Again, we've got distribution. Every power gets it, but don't forget that this 2 has a power of 1. It is not 2 times 4. It is 4 times the exponent. 4 times the exponent, 4 times the exponent, all the way across. So all your bases should stay the same. My base of 2 stays a base of 2. Now my 4 times 1 is a 4. My base of A stays an A. 4 times 3 is 12. My base of B, 4 times 4 is 16. My base of C, 4 times 2 is 8. And then lastly, to clean this up, 2 to the 4th power is 16, A12, B16, C8. Okay? All right. Length times width, right? Area equals length times width. So it's CD times CD. So area equals CD times CD. Oops. Not sure why I did that. Here we go. Area. Okay, CD times CD. No numbers to deal with, so just deal with your variables. Don't forget it's a 1 and a 1, a 1 and a 1. So you get C squared, D squared. Okay? Length times width. So this times this. So you have area equals 2x to the 5th times 3x squared. Well, 2 times 3 is 6. X times x, base, keep your base. 5 plus 2, remember you add when you're multiplying, is 7. There's your answer. Okay. 1/2 times base, which is 9p3, times height, which is 4p. Again, I'm going to ignore that 1/2 right now. And 9 times 4 is 36. P3 times P1 is P4. And again, is 36 divisible by 2? It is, so you can reduce this to, 18 P to the 4. Here you've got 1/2 times base, which is 4a squared c, times 6ac3. Kind of running out of room here. There we go. So again, ignore the 1/2 for right now. 4 times 6 is 24. A squared times A1 is A3. C1 times C3 is C4. And now these are the two I want you to put in your notes, okay? Last two for your notes, and then your notes will be complete for note check, and then you'll be ready to jump over and do the assignment. All right, area equals, this is, remember, area here is length times width, so it's just simply 6a squared b4 times 3ab squared. 6 times 3 is 18. AA, keep your A squared, and A1. How many A's do you have all together? You have 3. Base, keep your base of B. 4 plus 2 is 6. And last but not least is the last one for your notes. And we have area equals 1/2 times m cubed in p cubed. I really scrunched it there, didn't I? Times, well, let me scoot that over. That's just not going to fit in there. One half times m cubed in p cubed times m squared n cubed p4. Okay? Again, ignore that 1/2 to the end. So 1/2 times, no numbers to deal with here. So m, keep your m. 3 plus 2 is 5. Your n's, how many do you have all together? You got 1 here and 3 here, so that's 4. And your p's, you've got 3 and 4, which is 7. Now, the number that's not there but's there in front of this m is a 1. And 1 is not divisible by 2 evenly, and I don't want to put 0.5 m in, so this would be a case where your final answer would just be this monomial, which is m5n4p7 over 2, and you would leave it as a fraction. All right. Click on the load button at the bottom of the assignment to open up the Indicator 17 review in Kami, and make sure, just like I did here, all of the work that you see here, that's the work you need to show on your review, and then that is due tomorrow at the beginning of class. You'll have a chance to ask any questions, and then we will take the Indicator 17 quiz tomorrow at the beginning of class. Have a great rest of your E-Day, and of course you can email me if you have any questions.